In this video, we're going to determine the area of a circle, determine the area of a sector, calculate the area of a segment in a circle, and find the area of a shaded region. So remember from Unit 11, when we're finding the circumference of a circle, we are doing 2 times pi r. And when we're doing the area, we are using pi r squared. So in the first two, we want to find the area of the circle. So number one, we already have our radius is 12, so we have pi 12 squared, which gets us 144 pi centimeters squared. In number two, we have the diameter, so we know that the diameter is equal to 2 radii, so we're going to split that in half of 15. So when we go to find our area then, it's just pi 15 squared, which is 225 pi meters squared. In number three, the circumference of the circle is 50 pi. What is the area of the circle? So in order to get the area, we need to know the radius. So we know that their circumference is 2 pi r. So 50 is equal to 2 pi r. We can divide by 2 pi on both sides, and we get r is 25. So now we know our radius, and we can do pi 25 squared. So our area is 625 pi meters squared. So something we also talked a little bit about during Unit 11 was the area of the sector. So the area of a sector is the area of the shaded region that's formed by 2 radii. So it's basically like your slice of pizza or cake. So to find the area, it is pi r squared, which is the area of the circle, times the measure of the shaded region over 360. So how much of the actual circle are we looking at? So in number 4, we have a radius of 14. The shaded region is 70. So we would have pi 14 squared times 70 over 360. In our calculator, we're not going to put pi, we're going to put everything else. So 14 squared times parentheses 70 divided by 360. That comes out as a decimal, so we're going to hit math, enter, enter, and that turns into a fraction. So we have 343 over 9 pi centimeters squared. In number 5, our radius is 18. The non-shaded part is 60 degrees. So if we subtract from 360, we get the shaded is 300 degrees. So we have pi 18 squared times 300 over 360. So in our calculator, 18 squared times 300 divided by 360. And that's going to give us 270. So we have 270 pi inches squared. In number 6, we have a shaded region of 140 degrees with a radius of 30. So we have pi 30 squared times 140 over 360. So in our calculator, 30 squared times parentheses 140 divided by 360 is going to get us 350. So 350 pi meters squared. So in a circle, we have a segment of a circle, which is a region that is bound by an arc and a chord. So your area of the sector is going to be the area of the segment is going to be the area of the sector minus the area of the triangle that is whiting out part of that area of the sector. So in number 7, we have a 90-degree arc. We have a right triangle. So we know that the radius is going to be the same. So it's going to be the height and the base of our triangle. So we can do our area of our sector minus the area of the triangle. So we have pi 15 squared times 90 over 360 minus the area of the triangle. So 1/2 15 times 15. So when we multiply 15 squared times 90 divided by 360. Math, enter, enter. We get 225 over 4 pi minus 0.5 times 15 times 15. 225 over 2 centimeters squared. Now 8's a little more challenging because it's a 60-degree angle. So we need to draw in our radii, and because this is a 60-degree angle, we know that this is an equilateral triangle then because the radii have to be congruent, and so all of our angles are going to be 60 degrees. So all of the sides of the triangle are 80. So we would do the area of our sector minus the area of an equilateral triangle. So the area of our sector would be pi 8 squared times 60 over 360 minus root 3 over 4 times 8 squared. So as we are simplifying in our calculator, 8 squared times 60 divided by 360 math, enter, enter, and that gets us 32 over 3 pi minus, I'm going to put 8 squared divided by 4, which gets us 16 root 3 millimeters squared. In number 9, the angle is 120 degrees, so we can split that triangle and make the angle 60 and 60, so we have a 30, 60, 90 triangle. So if this 12 is my 2s side, 12 divided by 2 is 6. That's going to be the height of the triangle. Each part of the triangle then is going to be 6 root 3 and 6 root 3, so the base is going to be 12 root 3. So we can find our area then. So we have pi 12 squared times 120 over 360 minus 1/2 times the height of the triangle, which is 12, times 6 times the base, which is 12 root 3. So when we multiply them, we get 48 pi minus 36 root 3 feet squared. Now we're going to find the area of the shaded region. So in number 10, we have a circle with a hexagon inside it. So we know that the radius of the circle is 22 degrees. We also know that because it's a hexagon, when we do 360 divided by 6 divided by 2, we get the angle at the top is 30 degrees. So we have our special right triangle where the side is bisected, and that's the S side. Half of 22 is 11, which makes our apothem 11 root 3. So we can find the area of the circle and take away the area of the hexagon. So the area of the circle is just pi 22 squared. The area of the hexagon is 1/2 times apothem, which is 11 root 3, times the perimeter. So if the sides are all 22 and there are 6 sides, the perimeter is going to be 132. So we get 484 pi minus 726 root 3 millimeters squared. In number 11, the perimeter of the circle is 60, which means each side is going to be 40 because we're going to divide 160 by 4. So we get each side is 40. If I draw in 2 diameters of the circle, that makes each diameter 20. And if I cut that diameter in half, the radius of each circle is 10. So we would do the area of the square, which is 40 times 40, minus the area of 4 circles. And each circle is going to be pi 10 squared. So we get 1600 minus 400 pi feet squared. In our last problem, number 12, the radius of the circle is 20 meters. Triangle CUB is isosceles with the legs of 26. So if we know that the radius of the circle is 20, we also see from the picture that each side of the hexagon is 20. So first let's work on the triangle. So the triangle, we know that 20 is the side of this hexagon. When we draw in our height, and with the legs that are 26, we can do Pythagorean theorem because our side is split into 10 and 10. So we have 26 squared equals 10 squared plus x squared. 676 equals 100 plus x squared. 576 equals x squared. So x is 24. Once we know that, if we have the circle here, we can draw in our triangle to the hexagon. We know that our circle radius is 20. We also know that in the hexagon that 30 is the angle at the top. So we have 20 and 10 already, so our apothem is 10 root 3. So now that we have all of our information, to find the area, we're going to do the area of the circle minus the area of the hexagon, because that's in white, and then we're going to add the area of the triangle, which was shaded. So to get the area of the circle, it is pi 20 squared, which is 400 pi. To get the area of the hexagon, it is 1/2 times the apothem, which is 10 root 3, times the perimeter. Well, if each side is 20 and there are 6 sides, the perimeter is 120. So that's going to get us minus 600 root 3, and then plus the area of the triangle. So the area of the triangle, the base is 20, and the height is 24. So we get 240 meters squared.